How could something designed to never fail suddenly turn into a weapon of mass death? That was the question no one on the site asked that afternoon, because everyone believed the same thing. This crane could not fall. It had been sold as unbreakable, certified beyond industry standards, approved by engineers whose reputations were built on numbers, equations, and safety margins that supposedly eliminated risk. Standing over the construction site like a steel giant, the crane represented modern, industrial confidence, a machine meant to dominate gravity, not surrender to it. For months, the narrative surrounding this crane was absolute certainty. The manufacturer had promoted it as one of the safest lifting systems ever built. Project managers repeated those assurances during briefings. Inspectors signed off without hesitation. Workers below trusted it not because they understood the engineering, but because everyone in authority told them there was nothing to fear. When people say, disasters come without warning, they usually forget how much reassurance came before the collapse. The crane itself was enormous, visible from kilometers away, a landmark that defined the skyline. Every day, dozens of men walked beneath it carrying tools, steel beams, and expectations of another normal shift. Hard hats on, radios crackling, schedules tight. In their minds, danger came from slips, cuts, or fatigue, not from the towering structure above them. The idea that the crane could fail, catastrophically, simply did not exist in the collective imagination of the site. That confidence was reinforced by language. Words like redundancy, over-engineered, and fail-safe were used casually, as if they were shields against reality. The crane was said to have multiple backup systems, tolerances far above operational demands, and safety factors that made collapse statistically impossible. Engineers spoke in decimals and margins, and those numbers became a kind of superstition. If the math said it was safe, then it had to be safe. But safety culture often breaks, not with dramatic errors, but with comfort. Over time, certainty replaces caution. Procedures become routines. Checks become formalities. The crane had lifted heavier loads before. It had operated in worse conditions. It had passed every inspection. Each successful day reinforced the belief that tomorrow would be the same. That belief was stronger than any warning sign could have been. What no one acknowledged was that never is not a technical term. It is a promise, and promises in heavy industry are dangerous. Machines do not understand reputation. Steel does not care about confidence. Stress accumulates silently. Tolerances shrink invisibly. And systems fail not when people expect them to, but when conditions align in just the wrong way. On that afternoon, all the invisible factors were already in motion. The shift began like any other. Lifts were scheduled, radios checked, operators focused on precision and timing. No alarms sounded, no emergency stop was triggered. No one shouted to clear the area. From the ground, the crane looked exactly as it always had. Stable, dominant, unmoving except for the slow, controlled rotations that defined its purpose. Above the workers, tons of steel were suspended in perfect balance, until that balance began to lie. What makes this story unsettling is not just what happened next, but how unprepared everyone was to imagine it. The belief in invincibility had erased the possibility of collapse from everyone's mind. And when people cannot imagine failure, they cannot recognize it while it is forming. By the time reality asserted itself, there was no margin left, no time to react, and no escape from what gravity was about to claim. Before the crane fell, it had already succeeded in something far more dangerous than lifting steel. It had convinced an entire site that disaster was impossible, and that belief would cost 41 men there, lived in a single afternoon. If you're watching this story unfold, take a moment to reflect on the importance of understanding the unseen risks around us. Industrial accidents aren't just statistics, they are lives, families, and futures shattered in moments we often take for granted. Share your thoughts in the comments. What precautions do you think could have prevented this catastrophic crane collapse? Your insight might help others see the hidden dangers in everyday operations. And if this account of disaster and human error has caught your attention, make sure to hit the like button. It helps more people learn about the critical lessons from industrial tragedies. Don't forget to subscribe to the channel for more in-depth analysis of engineering failures, near misses, and the thin line between confidence and catastrophe. By engaging, you're not just watching a video, you're participating in remembering those who were lost and learning from events that should never be forgotten. The morning had started like any other on the bustling construction site. Yet beneath the routine, tension quietly threaded through the air. Dozens of workers moved with practiced efficiency, coordinating lifts, welding steel beams, and navigating scaffolding that rose like jagged teeth into the sky. Radios crackled with instructions, supervisors monitored schedules, and the giant crane towered over them all, an ever-present sentinel of steel. Its enormous boom cast long shadows across the site, a daily reminder of the power suspended above their heads, power they assumed was perfectly controlled. Unerring, invincible, the pace was relentless. Deadlines loomed, and productivity pressures mounted. Each operator, rigger, and laborer was acutely aware of the stakes, though the dangers they imagined were mostly procedural, slipping on wet surfaces, misplacing tools, or minor mechanical failures that could injure an individual. No one considered that the very symbol of industrial strength above them could become the source of total annihilation. The crane's reputation as a flawless machine had been reinforced by years of uneventful operation. Every successful lift was a silent affirmation of safety. Every rotation of the boom, a reassurance that catastrophe was impossible. Communication was constant, yet focused narrowly on efficiency. Orders were given, acknowledged, executed. Supervisors walked the perimeter, ensuring protocols were followed. Yet the very normalcy of the site created a blind spot, the assumption that the extraordinary, a complete structural failure of the crane, could not occur. In the minds of those on the ground, the steel giant above was untouchable, its certifications and engineering reports sacred. Every worker trusted implicitly that the equipment above had passed every test, every inspection, and that its operators were trained to perfection. Yet within the confidence, subtle deviations existed, unnoticed in the whirlwind of daily operations. Bolts tightened beyond specified torque, rigging adjusted with improvisation, small vibrations dismissed as inconsequential. Individually, these choices seemed minor, inconsequential, routine. Together, however, they were laying the foundation for disaster. It was not dramatic error or sudden malfunction that would bring tragedy, but a cumulative series of overlooked warnings, the quiet accumulation of stress on steel, the invisible erosion of the safety margin everyone assumed was unbreakable. As the afternoon approached, the workers continued their tasks under the crane's looming presence, unaware that the calm routine was a fragile illusion. Each lift, each swing of the massive arm, was a step closer to the inevitable collapse that the day's work unwittingly orchestrated. The machinery, the men, the deadlines, all intertwined in a delicate, precarious dance that would be shattered in an instant. The ordinary hum of construction equipment, the casual banter of crews, the rhythm of labor all masked the lurking threat. And when the first warning signals began to emerge, subtle creaks and slight shifts unnoticed in the cadence of work, no one paid attention, not yet realizing that every ordinary moment was accelerating toward a catastrophic climax. From a distance, the crane looked like a triumph of modern engineering, but its real power and its hidden vulnerability lived inside layers of steel, bolts, and calculations few on site truly understood. This was not a generic lifting machine. It was a high-capacity industrial crane designed to operate at the edge of what physics allows, capable of hoisting extreme loads while maintaining balance through a carefully calculated system of counterweights, tension zones, and structural redundancies. At the core of its design was the promise of margin. Engineers had calculated load limits well below the crane's theoretical breaking point. On paper, it could withstand forces far greater than anything scheduled that day. The boom was built from high-strength steel sections, engineered to flex just enough to absorb stress without deforming. The base anchoring system was reinforced to distribute weight evenly into the ground. Sensors monitored load distribution, wind tolerance, and rotational speed. Every component was designed to back up another component. Failure, according to the design philosophy, would require multiple systems to break at once, an event deemed statistically improbable. That belief became doctrine. Operators were trained to trust the readouts. Managers trusted the certifications. Inspectors trusted the documentation. Over time, the crane stopped being perceived as a machine and became an assumption, a fixed truth in the environment, like gravity itself. As long as the numbers on the screen stayed within limits, nothing else mattered. But machines do not fail only when limits are exceeded. They fail when reality diverges from assumptions. What the specifications could not fully capture was how the crane behaved under complex, evolving conditions. Loads were not static. Steel shifted slightly as it was lifted. Wind patterns changed between ground level and boom height. Thermal expansion altered metal dimensions across the structure as the day warmed. These factors were individually accounted for in design models, but not always together, not always under real-world improvisation. The counterweight system was especially critical. Its role was simple in theory: offset the load at the boom's end to keep the crane's center of gravity within a safe zone. But that balance depended on precise placement, correct configuration, and strict adherence to operational sequences. Small deviations, a counterweight adjusted out of sequence, a temporary repositioning left uncorrected, could subtly shift stress into areas never intended to carry it. Another overlooked reality was fatigue. Steel does not fail all at once without warning. It weakens over time. Microscopic cracks form under repeated stress cycles, invisible to the naked eye and often undetectable without specialized testing. Each heavy lift, each rotation, each moment of strain contributed incrementally to structural fatigue. The crane had passed inspections, but inspections are snapshots in time. They cannot always reveal what is slowly accumulating beneath the surface. Even the sensors, trusted as the final authority, had limitations. They measured what they were designed to measure, not what engineers never expected to go wrong. A sensor might confirm load weight while missing torsional stress. Another might track wind speed while ignoring harmonic oscillations building within the boom. Technology gave confidence, but confidence narrowed attention. The most dangerous aspect of the crane's design was not a flaw in steel or software. It was the assumption that redundancy equals invulnerability. Redundant systems reduce risk, but they also create psychological distance from danger. When people believe a machine is over-engineered, they begin to accept shortcuts that would never be tolerated elsewhere. Procedures soften. Deviations become habits. Habits become culture. By that afternoon, the crane was operating within its nominal limits, at least according to the instruments, but unseen forces were interacting in ways the original models never fully predicted. Stress was no longer distributed evenly. Certain components were carrying more than their share. The structure was no longer a unified system, but a series of compromised links pretending to be whole. And as the crane continued to operate, lifting and rotating above dozens of men, its design, once praised as nearly indestructible, was quietly approaching a point where recovery would no longer be possible. The machine had not failed yet, but it was no longer safe. It was simply still standing. Long before steel began to twist and gravity took control, the crane had already started speaking. Not loudly, not dramatically. It whispered through small irregularities that were easy to dismiss in a busy industrial environment where noise, vibration, and pressure were part of daily life. These were not alarms that shut down operations. They were deviations, subtle enough to be rationalized, explained away, or ignored entirely. In the days leading up to the collapse, operators noticed changes that felt off but not dangerous. Slightly different vibrations during rotation, a marginal delay in response when the boom shifted under load. Movements that felt less smooth than usual, but still within what people had learned to accept as normal variation. No single moment screamed danger, and that was precisely the problem. Maintenance logs contained small notes that never triggered escalation. Adjustments were made to compensate for perceived imbalance. Temporary fixes became permanent habits. A component that should have been replaced was resecured instead. A recalibration that should have paused operations was postponed to avoid delays. Each decision, viewed in isolation, seemed reasonable. Together, they formed a pattern of risk normalization. Weather conditions added another layer of complexity. Wind speeds were technically within allowable limits, but gust patterns at higher elevations were irregular. The crane's sensors measured averages, not sudden directional shifts. As the boom extended and rotated, those gusts introduced lateral forces that fluctuated unpredictably. Experienced operators felt the difference in the controls, but experience also taught them to trust their instincts only up to a point, and to trust the machine beyond that. There were also changes in load configuration. That afternoon required lifts that pushed the crane closer to its upper operational envelope, not exceeding limits, but compressing safety margins. Load shapes were uneven. Weight distribution was imperfect. Rigging configurations were adjusted on the fly to keep work moving. Nothing violated procedure outright, yet everything depended on precision that no longer existed. One of the most dangerous moments came when a minor alignment issue was identified and corrected without a full system reassessment. The fix addressed the symptom, not the cause. Stress that should have been redistributed safely was instead redirected into structural areas never designed to carry it. The crane continued to operate, but now under a new internal tension profile no one had calculated. Human factors played a silent role. Authority gradients discouraged escalation. Junior workers noticed inconsistencies, but assumed senior engineers had already considered them. Supervisors trusted previous inspections. Engineers trusted models. Models trusted assumptions. At every level, responsibility diffused outward until no one felt fully accountable for stopping the operation. There was also pressure, not malicious, but constant. Delays meant financial losses. Pausing work meant explaining decisions to management. Questioning a crane certified as exceptionally safe invited skepticism. Over time, the cost of caution began to feel higher than the cost of risk. That is how dangerous environments become normalized. By early afternoon, the crane had accumulated layers of unresolved stress. Structural fatigue, misaligned forces, environmental variability, and human complacency were no longer separate issues. They were interacting. What made the situation lethal was not that anyone ignored a single catastrophic warning, but that dozens of small warnings blended into background noise. When people later asked why no one stopped the work, the answer was simple and unsettling. Nothing looked wrong enough. The crane was still standing. The readings were still green. The lifts were still completing. Productivity had not slowed. From the outside, the operation appeared controlled, efficient, professional. But systems do not fail when people expect them to have been. They fail when accumulated strain reaches a point where correction is no longer possible. By the time anyone realized that the crane was no longer behaving like the machine they trusted, the window for prevention had already closed. And when the structure finally began to give way, it would not do so gradually or politely. It would fail suddenly, violently, and without giving anyone beneath it the time they would desperately need. If you were on that site, would you have recognized the moment when caution should have replaced confidence? Would you have stopped the operation or trusted the machine one last time? The collapse did not begin with a dramatic snap or an obvious failure that gave people time to react. It started with something far more dangerous, a movement so slight that most of the men beneath the crane never noticed it. In the middle of a routine lift, as the boom rotated under load, the structure shifted just a few degrees off its expected alignment. To an untrained eye, it looked like nothing. To the machine, it was the point of no return. Inside the crane, forces that had been quietly accumulating suddenly crossed a threshold. The redistributed stress moved faster than any human response could follow. A component deep within the structure exceeded its fatigue tolerance and deformed, not enough to break outright, but enough to transfer load violently into adjacent sections. That single deformation triggered a cascade. Bolts, designed to share load, were forced to absorb it unevenly. Steel members twisted against assumptions they were never meant to challenge. Witnesses later described hearing a sound that didn't match anything they knew. Not a bang, not an explosion, a deep metallic groan. The sound of massive steel protesting against physics. That noise lasted less than a second. By the time anyone looked up, the crane was already falling. The boom began to tilt, accelerating as gravity took over. Counterweights that had kept the structure stable became liabilities, pulling the base beyond its capacity to resist rotation. The anchoring system failed asymmetrically, tearing free in stages rather than all at once. That staggered failure caused the crane to twist as it fell, widening the zone of destruction below. Men scattered instinctively, but there was nowhere safe to run. The collapse was faster than human reaction time. Tons of steel descended in an uncontrolled arc, smashing through scaffolding, platforms, and temporary structures as if they were made of paper. The boom struck the ground first, followed by sections of the tower folding inward on themselves, releasing stored energy in violent bursts. Dust, debris, and shattered metal filled the air. Visibility dropped to zero within seconds. The impact sent shockwaves through the site, knocking workers off their feet even at the perimeter. Radios went silent, then erupted with overlapping shouts that dissolved into chaos. The entire sequence from the first imperceptible shift to total collapse took less than 10 seconds. What made the moment so devastating was its speed. There was no progressive failure to warn those below, no time to evacuate, no chance for corrective action. The crane went from operational to lethal almost instantly. Everything people believed about its safety became irrelevant the moment gravity asserted itself. When the dust began to settle, the scale of destruction emerged piece by piece. Steel lay twisted into unrecognizable shapes. Equipment was crushed flat. The worksite that had been full of movement minutes earlier was now a field of wreckage in silence. And beneath that steel, dozens of men were trapped, some instantly killed, others pinned, injured, and unheard. The most chilling realization came later, during reconstruction of the event. Investigators would determine that even if someone had recognized the danger at the exact moment failure initiated, there would have been nothing they could do. The physics were unforgiving. The system had passed the point where human intervention mattered. In that single afternoon, the crane proved the cruel truth that heavy industry rarely wants to admit. Catastrophic failures do not announce themselves. They arrive suddenly, decisively, and without mercy, turning trusted machines into instruments of mass death in the time it takes to look up. The moment the crane hit the ground, time fractured. What had been a structured, coordinated worksite dissolved into pure survival instinct. Men who seconds earlier were focused on tasks and signals now screamed names, clawed through dust, and ran toward wreckage without understanding what they were running into. The air was thick with debris and powdered concrete, burning lungs with every breath. Visibility was so poor that some rescuers stumbled directly over bodies before realizing what lay beneath their feet. Under the collapsed steel, there was no uniform outcome. Some workers were killed instantly, crushed by thousands of tons with no warning and no pain they could register. Others were trapped in silence, pinned in positions that made movement impossible but left them conscious. They shouted until their voices gave out, then banged on metal, then waited, hoping someone could hear them through the chaos. The sounds were overwhelming. Twisted steel continued to creak as it settled, each movement threatening secondary collapses. Alarms from damaged equipment wailed continuously. Radios transmitted fragments of panic, overlapping calls for help, broken sentences cut short by static or screaming. No one had trained for this exact scenario. Emergency protocols existed on paper, but reality moved faster than procedure. Rescue attempts began immediately, driven by instinct rather than planning. Workers used bare hands, tools, anything they could find to lift debris that was far beyond human strength. Some realized quickly that pulling at certain sections could make things worse, causing steel to shift and trap victims even more tightly. Others didn't realize until it was too late. In disasters like this, good intentions can be as dangerous as inaction. Within minutes, emergency services were called, but access was difficult. Roads around the site clogged with vehicles and onlookers. Firefighters and medics arrived to a scene that looked less like an accident and more like a battlefield. Triage began in open areas where the injured were dragged out and laid on the ground. Dust-covered faces stared upward in shock, some bleeding heavily, others eerily still. The numbers began to surface slowly. At first, no one knew how many were missing. Supervisors checked rosters with shaking hands, crossing off names as they were found alive or confirmed dead. Each unchecked name carried unbearable weight. Families would later say this waiting, the uncertainty, was worse than the final confirmation. As the scale of the tragedy became clearer, the site fell into a heavy, unnatural silence, broken only by machinery used to lift debris carefully, inch by inch. Every movement was calculated now, not for productivity, but for the possibility of survival beneath the steel. Time mattered, but rushing could kill those still alive. By the end of the first hour, it was clear that this was not just an industrial accident, it was a mass casualty event. 41 men would not leave that site alive. Some would never even be recognizable without forensic identification. Lunchboxes, helmets, gloves, personal items scattered among the wreckage became the most haunting evidence of how ordinary the day had been before it turned fatal. What makes this phase of the disaster especially brutal is its intimacy. These were not distant victims in a report. They were co-workers, friends, men who had spoken minutes earlier. The crane did not just collapse steel. It collapsed families, futures, and an entire sense of safety. In one violent afternoon, and as rescue operations continued into the night, one question echoed quietly among those still standing. How could something everyone trusted so completely destroy so many lives so fast? When the last immediate cries faded and the machinery slowed to a cautious crawl, the site entered a phase that survivors would later describe as more disturbing than the collapse itself. Silence settled in, not peaceful, but heavy, suffocating. The kind of silence that follows something irreversible. Floodlights illuminated twisted steel and shattered ground, casting long shadows that made the wreckage look even larger, even more unreal. What had been a living, noisy worksite hours earlier now felt abandoned, frozen in shock. Operations stopped completely. No schedules, no productivity targets, no supervisors urging crews forward. Every movement was deliberate, slow, restrained by the understanding that one wrong shift of steel could end another life. Rescue teams worked methodically, communicating in short, controlled phrases. The urgency was still there, but it was tempered by fear. Fear of secondary collapses, fear of making the wrong decision, fear of discovering what lay beneath the next slab of metal. Families began to gather at the perimeter as word spread. Some arrived with phones pressed to their ears, trying to confirm rumors. Others stood in silence, staring at the lights and smoke, hoping not to recognize a helmet or jacket among the debris. Officials struggled to control information, releasing nothing definitive, while names were still being matched to bodies. That vacuum of certainty created anguish. Every passing minute without news felt like a verdict delayed but inevitable. Inside the site, responders encountered moments that would stay with them for life. Tools still clutched in hands, radios still clipped to belts, transmitting nothing. Lunch breaks that would never happen. These details cut deeper than statistics ever could. They were reminders that this disaster interrupted ordinary lives in the most brutal way possible. As the hours stretched on, the reality became undeniable. This was no longer a rescue mission. It was a recovery operation. The tone changed. Movements slowed further. Commands softened. The hope that had fueled the first frantic efforts began to dissolve, replaced by grim responsibility. Each recovered body required documentation, care, and dignity. Each one reinforced the scale of the loss. Public statements were brief and cautious. Company representatives spoke of cooperation and sympathy, carefully avoiding explanations. Authorities promised investigations, but for those standing amid the wreckage, those words felt distant and hollow. Accountability could wait. Right now, there were still men under the steel. By dawn, exhaustion set in. Faces were streaked with dust and fatigue. Some responders sat on the ground in silence, staring at nothing. Others kept working simply because stopping would force them to think. The crane, now reduced to mangled fragments, loomed as a grotesque monument to misplaced certainty. In the quiet that followed the collapse, one truth became impossible to ignore. The disaster did not end when the crane hit the ground. It continued in the waiting, the uncertainty, and the realization that the lives lost could not be undone, no matter how carefully the steel was lifted away. And as the sun rose over the site, another process was already beginning, one that would determine not only what went wrong, but who would be willing to admit it. The investigation did not start with accusations. It started with measurements. Engineers, inspectors, and forensic specialists moved through the wreckage with cameras, scanners, and notebooks, documenting every twisted beam and fractured joint as if reconstructing a crime scene. Because in many ways, that is exactly what it was. A structure had failed. 41 men were dead. And somewhere, inside the steel, the truth was buried. At first, the official tone was careful and neutral. Statements emphasized cooperation, transparency, and patience. Authorities spoke of complex factors and ongoing analysis. The early assumption was that this would be a technical mystery, an unfortunate convergence of conditions rather than a preventable failure. But as data accumulated, that narrative became harder to maintain. Investigators began by reconstructing the crane's final hours. Load charts were compared against operational logs. Sensor data was extracted and aligned with timestamps. Wind conditions were analyzed minute by minute. On paper, the crane appeared to have operated within allowable parameters. That alone raised concern. If the numbers were correct, the collapse should not have happened at all. Attention shifted to structural components. Metallurgical testing revealed fatigue fractures that had existed long before the collapse. These cracks were microscopic, invisible during routine visual inspections, but unmistakable under laboratory analysis. They told a story of repeated stress cycles that exceeded what the structure had been designed to endure, not in one dramatic moment, but over time. Then came the uncomfortable questions. Why had these stresses accumulated? Why had inspections not detected them? Why had warning signs failed to trigger shutdowns? As investigators dug deeper, they found a pattern. Maintenance schedules had been adjusted to accommodate project timelines. Non-critical deviations had been logged, but never escalated. Temporary operational changes had quietly become permanent. None of these actions violated safety rules outright, but together, they bent the system closer to failure with every passing day. Human factors analysis revealed something equally troubling. Decision-making had become fragmented. Responsibility was spread across departments, contractors, and oversight bodies. Each group trusted the others to manage risk. Engineers trusted operators. Operators trusted sensors. Managers trusted certifications. When everyone is responsible, no one truly is. One of the most damning findings involved assumption-driven safety. Investigators concluded that confidence in the crane's over-engineered design had reduced sensitivity to abnormal behavior. Operators had noticed changes, but dismissed them as acceptable variation. Supervisors had seen small anomalies, but relied on past performance to justify continuation. The system did not fail because people ignored danger. It failed because danger had been redefined as normal. As preliminary findings leaked, public pressure intensified. Families demanded answers. Media scrutiny increased. Experts outside the investigation began to speak openly about systemic negligence, pointing out that catastrophic failures rarely stem from a single mistake. They emerge from cultures that reward efficiency over caution and certainty over skepticism. By the time the interim report was released, one conclusion was unavoidable. This was not an unforeseeable accident. It was a foreseeable outcome of layered decisions, compromised margins, and unchecked assumptions. The crane did not collapse because it was defective. It collapsed because the system surrounding it slowly removed its ability to survive error. And as the investigation continued, another reality became clear. Uncovering what went wrong was only the beginning. Admitting it, and deciding who would bear responsibility, would prove far more difficult. As the investigation moved beyond engineering data and into decision trails, a second collapse began, not of steel, but of credibility. Documents that initially appeared routine started to contradict public statements. Timelines shifted. Testimonies softened. What had been described as transparent cooperation slowly revealed fractures that mirrored the crane's own failure. Internal reports surfaced, showing that concerns had been raised weeks before the collapse. Emails referenced non-standard behavior during certain lifts. Maintenance notes mentioned recurring adjustments that should not have been recurring at all. None of these documents, on their own, proved negligence. But together, they told a story that no press conference could neutralize. People knew something was wrong, and work continued anyway. Company representatives insisted that all procedures had been followed. Legally, that statement was defensible. Safety protocols had not been violated in a way that triggered mandatory shutdowns, but investigators uncovered a deeper issue. The protocols themselves had been interpreted with flexibility that favored productivity. Risk assessments were framed to justify continuation rather than interruption. Language mattered. Phrases like acceptable deviation and temporary condition appeared repeatedly, stretching their meaning further each time they were used. Witness accounts began to diverge. Some supervisors claimed they were never informed of irregularities. Others acknowledged awareness, but said they believed the issues had been resolved. Junior staff described hesitation to escalate concerns, fearing backlash or dismissal. No single lie stood out. Instead, there was a fog of half-truths, omissions, and selective memory, the kind that thrives in complex organizations when blame threatens careers. The most damaging revelation involved documentation gaps. Certain inspection records were incomplete. Some sensor anomalies were flagged but never followed up with full analysis. In a few cases, data that should have been preserved was overwritten or lost. Official explanations cited system limitations and routine data cycling. Families heard something else. Evidence that might have clarified responsibility was gone. Public messaging focused on tragedy, sympathy, and commitment to safety improvements. Privately, legal teams worked to narrow liability. Statements were crafted, Carefully, avoiding language that implied foreseeability or preventability, the narrative shifted from what went wrong to what can be learned, subtly moving attention away from accountability. Experts watching from the outside recognized the pattern immediately. This was not concealment in the dramatic sense. It was dilution. Responsibility spread so thin that no single decision appeared decisive. No individual action seemed fatal. The system itself became the culprit, abstract, faceless, and difficult to prosecute. For the families, this phase was devastating in a different way. The loss was no longer just about death. It was about truth. Every withheld document, every evasive answer, deepened the sense that their loved ones were being reduced to liabilities rather than lives. Closure felt impossible when honesty seemed negotiable. By the time formal hearings concluded, the technical causes of the collapse were well understood. What remained contested was moral responsibility. And in that space between knowledge and accountability, trust collapsed completely. The question was no longer how the crane fell. It was how many decisions had been quietly made to ensure no one would truly answer for it. Long after the wreckage was cleared and the headlines faded, the consequences of the collapse continued to unfold in ways far less visible than twisted metal. New regulations were announced. Safety bulletins circulated. Industry panels promised reform. On paper, the disaster became a catalyst for change, a reference point cited in training manuals and engineering conferences as an example of what must never happen again. Design standards were revisited. Load monitoring systems were updated to capture more complex stress interactions. Inspection protocols expanded beyond visual checks, incorporating deeper fatigue analysis and more frequent non-destructive testing. Some crane models were retrofitted, others were quietly retired. The industry spoke the language of learning, of progress, of prevention. But legacy is not defined only by what changes, it is defined by what repeats. In the years that followed, similar collapses occurred in different places, under different names, involving different companies, but with hauntingly familiar patterns. Certified machines, experienced operators, acceptable deviations, tight schedules, small warnings dismissed. Each incident came with its own explanation, yet the structure of failure remained the same. Confidence eroded caution. Assumptions replaced skepticism. Systems optimized for efficiency slowly lost their capacity to absorb error. What this disaster truly exposed was not a flaw in one crane, but a flaw in how heavy industry defines safety. Safety is often treated as a condition, something a machine either has or does not have. In reality, it is a process that degrades when attention narrows, when pressure builds, and when success convinces people that failure belongs to someone else. The 41 men who died that afternoon became more than victims of a single collapse. They became evidence of a systemic blind spot, the belief that advanced engineering can eliminate human responsibility. That belief is comforting, profitable, and dangerously false. Machines extend human capability, but they also amplify human error. When something goes wrong at scale, the consequences are unforgiving. For families, the legacy is deeply personal. Birthdays marked by absence, chairs left empty, questions that never receive answers strong enough to justify the loss. No regulation can restore what was taken. No report can translate accountability into closure. What remains is memory, and the demand that those memories mean something beyond a footnote in industrial history. For workers still walking beneath cranes today, the legacy is quieter but just as important. It lives in moments of hesitation, in decisions to speak up, in the refusal to accept never as a guarantee. Every time a warning is taken seriously, every time work is paused despite pressure, the past asserts itself in the present. This story does not end with reform or resolution. It lingers in the uncomfortable truth that catastrophic failures are rarely caused by ignorance. They are caused by familiarity, by the slow erosion of doubt, by the moment when a system convinces everyone involved that nothing can go wrong right before everything does. And as long as that mindset survives, the question is not whether another crane will fall. It is where and how many people will be standing beneath it when it does. If you made it all the way to the end of this story, it means you understand that industrial disasters are never just accidents. They are warnings written in steel and silence. Take a moment to leave a comment below and share your thoughts. Tell us what struck you the most in this tragedy, or comment the word remember to show that these 41 lives are not just numbers to you. If this analysis helped you see industrial safety in a new way, make sure to hit the like button. It helps this content reach more people who need to understand how easily confidence can turn into catastrophe. And don't forget to subscribe to the channel for more in-depth stories about industrial failures, hidden risks, and the lessons written in disasters the world tries to forget. Now, keep watching. The next video on your screen dives into another industrial tragedy, where the warning signs were there and ignored.